Alright, welcome back. We're in part 2 of our lecture now about the business of the future of climate. And remember, we've been trying to talk about how interdisciplinary teams of scientists created different scenarios for the future, the rest of the 21st century basically, based on the IPAT relationship. What can we figure out about possible ways in which the population could change, possible ways in which affluence could change, possible ways in which technology changes, that could tell us about what are the range of possible futures, what are some scenarios about how the rest of the 21st century could happen, and then we'll use that as boundary conditions to drive our climate model. Alright, so different organizations like IPCC and AMIP, the Atmospheric Modeling Comparison Project, have developed these scenarios. Now the particular scenarios we're talking about first, this is going to be A1. You may be familiar with these terms. This is going to be like A1 and B1 and A2 and B2. There are different scenarios for the future. These scenarios with these letter number combinations are a little bit out of fashion. It's a contemporary climate science in the last year or two has, maybe even more than that, maybe more like 3 or 4 years now, has been shifting towards a different notation that we'll start talking about in the next lecture to describe these different climate scenarios of the future. But it's still useful. All existing climate science is going to be our, when you pick up a paper or you pick up a textbook, is going to be talking about climate scenarios of the future in terms of A1 and A2 and B1 and B2. And so we'll talk about the ways that this is changing in the next lecture. But for now we're going to talk about each of these scenarios. And because the actual way in which they formulated each of these 4 scenarios for the future is important, I actually did what I hate to do, and that is put way too much text on a slide. That's a direct quote from, in this case I believe it is from the IPCC AR5. So here is A1. Again, these things are described in your readings and so on, but A1 is the storyline that describes a future world of rapid economic development, where the rich and the poor all are going to gain wealth. That A term is growing rapidly, leading to a reduction in the wealth gap between the rich countries and the poor countries, and a reduction of poverty. That means more of those people that are out there in the world, in a rapidly growing world, are also using more goods and services. And because the wealth gains of the poor, the population growth is going to be diminishing. As you make poor people in developing parts of the world richer, they are having slower population growth, generally due to changes in the role of women and so on, which is going to be one of the more optimistic scenarios with regard to population. It's going to say that population growth is going to diminish, and population globally actually peaks around the year 2050, and then it declines after that. There's also a rapid introduction in this scenario. We're saying, kind of in a rosy sort of view, that we're going to be introducing new technologies that reduces the carbon intensity and energy intensity of the economy. Okay, so we have this A1 scenario, and actually within the A1 scenario there's actually several, I can't think of exactly what the terminology they use is, it's not sub-scenario, but you can think of that. Oh, it's a family of scenarios, I believe is the way they put it, where there are different, like for example, if this graph here shows over the course of the next 100 years, the total carbon dioxide emission in terms of gigatons per year. So this is not temperature on this graph, this is the economics of it. This is the carbon we're emitting. And you can see, for example, in the A1B scenario, you can see how the amount of carbon dioxide we are emitting each year peaks somewhere around the year 2050 and then starts slowly decreasing towards the end of the 21st century. A1B is the scenario that is often referred to as the business as usual scenario. That's the scenario where basically we're going to let market forces keep expanding how we find fossil fuels until it becomes not financially, it doesn't make financial sense anymore to find fossil fuels, and it makes more financial sense to do things like wind and solar. But you can see that there's related scenarios like A1FI, which stands for fossil fuel intensive future, where we keep using technology to find more and more difficult sources of fossil fuels, like fracking and tar sands and so on. We're kind of on the A1FI scenario right now. I mean, take a look at these. By the way, you see how there's some error bars on there. You can see there's a range of estimates as to what different experts think we could have for our carbon dioxide emissions. We currently are emitting about 9 gigatons of carbon per year from anthropogenic sources, and you could see that in some of these more dire scenarios, it could be as much as 35 gigatons per year by the end of the 21st century in the A1 scenario. On the other hand, for example, there's A1T, which is a family of scenarios and estimates in which, well, maybe we could actually use technology particularly well to reduce the carbon intensity of the economy and so on, in which case we can actually start reducing the total amount of carbon dioxide we're emitting, although notice that we're still nowhere near zero, right? We're still, even at the end of the 21st century, emitting a fair amount of carbon dioxide into the atmosphere from anthropogenic sources. Now, related to the A1 scenarios are the so-called A2 scenarios. And this is a storyline that describes the world with fast economic growth, but the growth is not very evenly distributed, where the rich get richer and the poor get poorer. There are complicated sociological and economic consequences to widening the gap between the rich and the poor that have unfortunate consequences for rule of law, international security, role of women, etc., and have unfortunate consequences with regard to like carbon dioxide emissions and so on. Consistent with the poverty that is rampant in this particular scenario, the global birth rate remains high, and there's a booming population throughout the 21st century. Because of the uneven economic growth, technological development is slower than it is when the economic growth is more democratic, and when the deployment of new technologies occurs, it only occurs in the more developed parts of the world. It isn't in general shared with the poorer, higher population parts of the world. This is not a good future for any of us. And if you take a look at the A2 scenarios, again, this is just their carbon dioxide emissions. This is not temperature on this graph right here. What you see is there's a range of estimates that are in here, but all of the A2 scenarios are terrible. Okay, we go from 9 gigatons of carbon dioxide being emitted per year now to, by the end of the 21st century, we're up around 29 gigatons per year, possibly as high as like 35. Okay, if we get onto the A2 future scenario, we have a vastly bigger greenhouse gas problem to deal with. But there are more optimistic scenarios. For example, B1. B1 is a storyline that describes a world where economic growth is evenly distributed between the rich and the poor. Economic growth is relatively slow compared to the A1 scenario, but it is more it's more democratically distributed around the world. It is more based on sustainable growth. It is based more on environmental protection. It is based more on social justice, and this storyline has the same kind of relatively beneficial situation where global population peaks around the year 2050 because of the growing wealth in the developing world. The world economy switches more towards a service economy and more towards an information economy that aren't as greenhouse gas intensive as like a manufacturing based economy. And so there's improvements in energy intensity, and the introduction of clean and resource efficient technologies helps, and so on. These B1 scenarios are pretty nice. Now, just to give you a sense of what they look like over the next 100 years, again, this is carbon dioxide emissions from anthropogenic sources on the right. This is not global mean temperature or anything like that. But these B1 scenarios look better, which the report actually indicated by having the error bars around it in green. These are the scenarios where there are global solutions that build up everybody, reduces gaps between the rich and the poor, reduces birth rates, a green economy based on services. And even with this is the Star Trek solution, right? I mean, we have a happy future with everybody. We're not short on resources for anybody and so on. It still takes a long time, though, even in this really nice scenario, for the emissions to even get to their current levels. I mean, if you follow the graph across from where we are now, it takes until like the year 2060 for emissions to even get as low as they are now, and we're not happy with our current emissions. And even by the end of the 21st century, we're still emitting an awful lot of carbon dioxide into the atmosphere in this really rosy scenario. And then there's B2. B2 is the fourth of the storylines that we're going to be talking about, or scenarios. Storyline is another vocabulary word that is used in certain contexts when discussing these different scenarios. This storyline describes a world where economic growth is very unequally distributed, where the rich get richer and the poor get poorer. And that doesn't mean like in any individual country, although that may be true too. I mean as in like the third world goes terrible and the economic development falls apart in that part of the world, whereas the rich countries get richer. Population increases continually, although admittedly at somewhat of a slower rate than A2. There's usually a shift towards more local solutions to problems. That doesn't sound like such a bad thing until you understand the B2 scenarios are generally the global economy falls apart. Usually it's something like a large war between major players in the 21st century results in we no longer really do global trade. The global economy falls apart. That is an awful thing for certain reasons, but it's not necessarily an entirely awful thing for climate change reasons, because, I mean, part of the problems we have now have to do with global trade, right? It's a complicated scenario about things going wrong. Everything falls apart in the B2 scenario. And goods and services are produced locally, but not necessarily all that efficiently, not that evenly, etc. I mean, at first blush, B2 doesn't sound so bad. I mean, it talks about things like local solutions, emphasis on local sustainability, local economies, but it just doesn't work played out over 100 years. Solutions that make one economy more efficient don't spread to other economies in a world that's not sharing technologies and so on. There isn't global trade putting pressure on different economies to become more efficient and so on. It just doesn't work out. What sounds at first like not a bad scenario for the future, in fact, turns out to fall apart for all kinds of technical reasons. B2 is not the worst scenario. You can see we go from about 9 gigatons of carbon per year now to about 15 gigatons or something like that by the end of the century. It's by no means our worst scenario, but it's by no means our best either. And frankly, how we get to B2 is not pretty. Okay, the B2 is kind of a future we don't want to be on. And so we have this system of 4 different families of scenarios here, okay, storylines of scenarios here. And I want you to notice that there's a bit of a pattern here. The ones that start with A are the scenarios that have high economic growth. They are assuming that the world's affluence is going to continue growing. Whereas the B scenarios are assuming that the growth will be slower, whether for relatively happy reasons, like in B1, where we've emphasizing growth of the sustainable economies and so on, or B2, where the global economy falls apart. Both of those have slow economic growth. On the other hand, if you sort them the other way by the number at the end, the ones that end in a 1 have this relatively rosy possibility that the gap between the rich and the poor decreases. The poor are lifted up, and that has positive impacts on things like the population and so on, and social justice and so on, whereas the A2 and the B2 scenarios, the ones with 2 on the end, have very dire problems due to the gap between the rich and the poor widening rather than becoming smaller. But I want you to have noticed something about all these scenarios. None of them save the world. None of them are the solution to all of our problems. Notice how even in the rosiest of scenarios, things still went wrong. We still had a surprising amount of carbon dioxide being emitted into the atmosphere, even under the best possible circumstances 100 years from now. What on earth is going on? I mean, if we take a look here at this diagram here, now I recognize I kind of have things overlapping on here, but this again is carbon dioxide emissions. We're not yet looking at things like temperature and so on. But if we go ahead and just sort of take, the 1990 emissions rates there and just sort of draw a straight line across so you can get a sense of which ones have involved increases and which ones have involved decreases in the amount of carbon dioxide we're emitting, you can see that only really the most extremely optimistic scenarios, namely B1 and A1T, ever even get their emissions back to the 1990 levels. And we weren't happy with our amount of emissions back in 1990. Remember, B1 was that sort of very slow growth, emphasis on sustainability, emphasis on global solutions, etc., the Star Trek solution. And A1T is the one where we really have some breakthroughs in technology, power generation and power distribution and so on. We have fast economic growth, but it's happening using almost completely clean technology. Both of those are frankly kind of unrealistically positive scenarios, and they're the only ones that ever get the emissions back just to 1990 levels, much less, fixing the problem. This is a big deal. The B1, which I have here highlighted in black, does manage to have the lowest emissions due to its very low population growth and how the population peaks around 2050, and also its emphasis on sustainability. This is the idea that there'll be these global solutions that distribute efficient technologies like wind and solar and so on, and clean energy and so on globally. Okay, that's a really good scenario, but there's a lot of reasons to think that's not going to happen. The A2 scenarios, of course, are a disaster. Those are the ones with high population, high inequality, high emissions, And you can see that there's even worse ones out there. I mean, the A1FI, which by the way is kind of the one it looks like we're on, where we're using technology to find more fossil fuels rather than, like fracking and tar sands and so on, rather than using technology to avoid using fossil fuels. Rats. We're on some very bad curves here, but they're all just different scenarios for the future. And so if you take those different scenarios and you draw a line out there, so like we're extending the line from 1950 to 2100. I drew on there in the red line there the pre-industrial carbon dioxide concentrations, which were around 260 parts per million. So this is not emissions that we're seeing on here. This is what the atmospheric concentration will be of carbon dioxide based on the emissions we saw on the last slide. Well, of course, if the amount of carbon that we are adding to the atmosphere is positive, we can only be increasing. Even in the happiest of these scenarios, we're still adding carbon dioxide to the atmosphere. So the carbon dioxide concentration in the atmosphere continues to go up. I mean, like you can see B1, one of our happiest scenarios, which is the green one, still has carbon dioxide increasing all the way out to the end of the 21st century. Notice that based on carbon dioxide concentrations at the end of the 21st century, we could now know the carbon dioxide concentration in the atmosphere, or at least we have a range of possible carbon dioxide concentrations at the end of the 21st century. And from that information, we can use things like Lambert-Beer's law to determine the radiative forcing that would exert on the climate at that time. And in fact, you find out that it's awful. Turns out the range of radiative forcings on the Earth climate system at the end of the 21st century ranges from about 4 to 8 watts per square meter. Remember radiative forcing from previous units? This is this idea that that's like how much imbalance there is between the amount of energy going in and the energy going out. You might remember that at the present time, the radiative forcing on the climate, the imbalance is about 0.6 watts per square meter. Oh. 0.6 is smaller than that number of 4 watts per square meter. That's the really optimistic scenario where we did everything we could to really make a global economy where the world was sharing solutions and had a sustainable economy, and we have a radiative forcing vastly greater than the one we have now. And of course, 8 watts per square meter. Again, that's a whole order of magnitude higher than the radiative forcing now. In fact, these radiative forcings at the end of the 21st century are absolutely terrible. These are huge radiative forcings. They're among the biggest that we've seen in the last 500 million years. We've only seen bigger radiative forcings at extreme events like comet impacts and things like that. Oh, this is very, very bad news. Now, that radiative forcing that you are seeing there, we couldn't, and in fact they do, partition that then. How much of that is due to the aerosols that we're adding to the atmosphere? How much of that is due to the methane that we're adding into the atmosphere? How much of that is due to changes in albedo as we have more urbanization, blah, blah, blah. It turns out about 80% of that radiative forcing is directly due to the carbon dioxide itself. Okay? So clearly carbon dioxide becomes the primary factor that we can control that is determining what the climate is going to be like at the end of the 21st century. All right, now, building on that information, then we're going to move forward into the third part of this lecture. But first, let's do a couple quick questions about what you just saw. Question 4. By the year 2100, the scenarios with the lowest carbon dioxide concentrations in the atmosphere are the ones with blank population and a blank economic gap between the rich and the poor. And then high, large, high, small, low, large, low, small, which is the right combination. So what you're going to want for population and economic gap between the rich and the poor to make the best possible future. Make a choice from those 4 options, get a little feedback before you move on to question 5.